Okay, so oops, I mean to go there. Okay, I just wanted to catch up with some. To talk a little bit more about that. Okay, so let's say Donald is suspected of downloading pictures of ducks. You want to form some questions. If you're asked to investigate this, you form questions. When, how, you start with leads, you end up with keywords, times, locations, say duck and Donald could be times, keywords. Use plats on the image or just on the sample artifacts. So I have a collection of sample artifacts you can use. You might start a spreadsheet, open the file. Now these files can have hundreds of thousands of entries, so they might be too big. You could filter on something, search for duck. You could just do a search for Chrome in your search for duck. You can come up with new keywords. You might find URLs that somebody's visited and things like that. And you can find times, you can find interesting folders, you can search for users, and you can find more information that way. So timeline analysis is basically find an interesting lead. And a line at a time. Each lead you follow may generate new leads, or it may fritter away. But you must follow this idea methodically. Okay, so for example, you might see the browser used. When was it installed? When was it run? Was there a file downloaded? Are there other files in that directory? Look at those file names and file times. They might give you new keywords and new times to search. So this can technically go on for a long time. So normally what you do is you collect some initial leads, and as long as there's more time, all the questions are not answered, that should be in poke in my code, take the best current lead and use it to generate new leads. Eventually, you should be able to answer all the questions, and you say, great, we have enough information now and I can go ahead. So that's a sort of the process. Again, if you follow that methodically and clearly eliminate leads, and once you've had the new leads, eventually, if you did follow all the leads through, it would take you a very long time because there are so many, and this is something you'll see shortly. So, generally timeline, keyword search, the suspect VM and file locations will be used continuously, and you pivot between them. You find something in one view, say in the timeline, that might cause you to do a keyword search. Now you can search the timeline, but a keyword search will search inside the files, and autopsy will allow you to do that. The suspect VM will allow you to check things out yourself. You can directly run, say, process monitor to check an artifact that you found in the timeline. And obviously file locations you can also check using usually autopsy. So this is how you work. It's a very straightforward process, and you can find that information very quickly. Okay, so here's some example searches with say a timeline. So let's say you've created the timeline, and you can search, for example, grep is the Linux search program. You can tell it you want to use regular expressions and ignore case. So the capital E is for regular expressions and the I is to ignore case. And this will allow you to search for either Chrome, Duck or Donald. And you might even just be interested only in those initially. You can do the same thing, and you can search for Chrome and then search for prefetch, so you can find whenever Chrome occurs in the prefetch. Again, -I is recommended, especially as the Microsoft Windows operating system is case insensitive, so you might get either version coming up. You could search for index.dat, and normally you have to backslash the dot because that can match anything, and then you can search for the file colon. Remember, if index.dat is the history file for Internet Explorer, but it's also used for the File Explorer, and in that case the entries will contain file colon. So you can search index.dat for all entries relating to files, and you can see which files were accessed on a computer. So this is again a powerful search. However, it is a little bit clunky. Okay, you can fix this using Elasticsearch and Kibana. You'd install Elasticsearch. This is a little bit awkward, but there are instructions for it. And then you can run piece sort, but instead of specifying that it's going to be an L to T CSV file, you can specify Elastic. And as long as you have Elasticsearch running, that data will be stored in Elasticsearch. For various reasons, you should also add the option ---- raw fields. You then need to install Kibana. Now there are instructions here. It's a little bit out of date. It's actually simpler than it was, but this gives you the main outline. And once you have that, then you can see Kibana running. And best way to understand it is to actually see it.